Good afternoon, 200% here. Uh, Now we're going to discuss about construction and working principle of switched reluctance motor. This is our second unit of special electrical machines. This is second unit syllabus. The syllabus of second unit is constructional features, working principle and operation of switched reluctance motor and torque prediction equations. Next one, characteristics of switched reluctance motor. Here the characteristics we are discussing speed and torque relationship. Then what are the power controllers methods are available using power semiconductor switching devices. Then uh, control of SRM drive. That means if you are using sensor, okay, closed loop control, open loop control and closed loop controls are there. Okay, both types we are discussing under the topic of control of SRM drive. And next topic is without sensor, how can we control the output parameter of switched reluctance motor? That is a sensorless operation of switched reluctance motor. And finally, where we are using in switched reluctance motor. Okay, the topic is applications. First, introduction. What is meant by switched reluctance motor? Everyone know. Okay, switched reluctance motor is just like a stepper motor. In stepper motor, full operations is controlled by stepper. Okay, here the switched reluctance motor is fully controlled by reluctance torque. Okay, if your mechanical design, power does not have delivered to moving part. Okay, so it's very easy of design. But in electrical design, switching systems need to deliver the power of corresponding windings. So it's very complicated. Okay, in SRM, mechanical designs are very easy. That means not much more difficult compared electrical design. Okay, and one more thing, the switching time is very precious. Electronic devices are precisely controlled only for. Okay, so here the construction is two types of rotation. One is here rotary, another one is here linear. Okay, first thing, rotary switched reluctance motor. The stator and rotor, two parts are there. Stator is made up of silicon steel stampings. Okay, rotor is made up of silicon steel stampings, but that stator is inward project. You want to see this diagram? Okay, this one is a inward projections. This one is a rotor. Okay, this one is a inward projections. And one more thing, stator poles and rotor poles. Okay, the count is not equal. Okay, some of the cases, stator poles are more higher than rotor. Some of the motors, stator poles and rotor poles are equal. Okay, but in switched reluctance motor, number of stator and rotor poles are not equal. Maybe the stator poles odd numbers or even numbers. Okay, many of the cases we are consider the number of poles is even number, but in particularly switched reluctance motor, the stator poles are maybe odd number or even number, depend upon the applications. But all the stator poles carry field coils. Okay, these field coils are connected in series such that MMF are additive. Okay, that is a phase windings. Okay, individual coils constitute to form phase windings. Okay, each of the phase windings are connected to the terminal of the motor. Okay, these terminals are suitably connected to the output terminal of power semiconductor switching circuits. Here the input is DC supply. Okay. This is the constructions of rotor. And next we're going to discuss about constructions of rotor. Rotor also made up of silicon steel stampings, but the notable point is outward projected poles. Okay, in stator made up of silicon steel stampings, but inward projected poles. Rotor is outward projected poles. Number of poles of rotor is different from number of poles in stator. For example, if stator poles are 6, we are consider rotor poles of 4. Okay, some cases the stator poles are considered 8, the rotor poles of 6. But the rotor shaft carries position sensor. Okay, this position sensor output depend upon turn on and turn off operation of power semiconductor switching circuitry. Okay, this power semiconductor switching circuitry output is fully depend upon rotor position sensor output. This is very important point. Okay, this is our construction. The outermost area is yoke. Okay, in this yoke, we will clearly show that is stator poles. 1, 2, 3, 4, 5, 6. 6 number of stator poles. Okay, in rotor poles, 4 poles. A dash, B dash. In small a dash, small b dash is indicated as a rotor. Okay, capital A1, capital A2, capital B1, capital B2, capital C1, capital C2. Okay, this indication is required as stator pole. In each stator poles having a coils, that coil is indicated as a field coil. The rotor is connected shaft. Okay, the working principle of switching electricity. The stator pole axis and the rotor pole axis are aligned as shown in the figure. See this diagram. Okay, this is a yielding stage. The stator poles and the rotor poles are aligned in same line. That means vertical. Okay, in this condition, the reluctance position is minimum. In this condition, minimum reluctance position. So far, the phase winding is concerned. So dLA by d theta value is 0. At this position, induction V winding is maximum, not minimum. Okay, so there is existing of dLB by d theta and dLC by d theta. If B phase is energized, the rotor develop a torque because variable reluctance, existence of variance in inductance. So the torque developed value is equal to of IB square, rate of change of LB with respect to angle. The direction is such that B dash, that means capital B dash means stator, small b dash is a rotor, try to get aligned. Here the torque is more than opposing load torque and the frictional torque, so the rotor start rotating. Okay, for example, the angle theta is equal to 30 degree. Okay, no torque is developed in the position of dLB by d theta equal to 0. Okay, here the electrical power is converted to mechanical power, takes that place. Again, the load torque increase, automatically the speed is reduced. We know the load torque is inversely proportional to speed. So power balance to be maintained, the speed developed to the same speed. For that, we are increasing the current. Okay, so more power is get from the supply. This is rotary converter.